All right, let's go ahead and get started. So thank you everyone for hopping on to our second tech talk brought to you by Awesome Software. Um, we, okay, so my name is Edgar Licea. I'm a marketing coordinator here with Awesome Software, and we're really excited to have here with us an amazing guest speaker all the way from Italy. So everyone say hi to Francesco. Uh, Francesco Ciulla.
Perfect.
Hey, all right, that's fantastic. So Francesco is a computer scientist. He's interested mainly, he's interested in Web3. He's worked from 2017 to 2020 on the Copernicus project for the European Space Agency. He's also a Docker captain since June of 2021. He's been a host for the official Docker All Hands in September of 2021, and a guest on the official Docker YouTube channel. He also has his own YouTube channel and his own Twitch, and he's on Twitter. So you should definitely give him a follow on all those social platforms. He's interviewed more than 148 developers on his YouTube channel, and he's currently head of DevRel at daily.dev. He's created a cool community of content creators to help each other and stand out in the world of content creation. Yeah, so again, just thank you so much for hopping on with us and teaching us a couple of things here about Docker.
Perfect. I think I need to see this introduction again because that was perfect. I'll take this as my elevator pitch in the future. Thank you so much.
Hey, no problem. And then here also to help us with the moderation and really be able to get into the weeds of Docker, I have Fede Ojeda. He works for Awesome Software as a software engineer, and he's passionate about computer science, software, development, design, architecture. He started working on mobile applications, but now is a full stack developer. He uses technologies such as Docker, Node.js, Python, and React. He's also worked on a wide range of projects, so very qualified and really excited to have him come and moderate this tech talk with us.
First, thank you very much for the intro, Edgar. I'm really happy to be here.
Alrighty. Okay, so before I turn it over to Francesco and Fede, I want to tell our audience a little bit about Awesome Software. So I have some slides for us. Okay. So Awesome Software was founded a couple of years ago here in Austin, Texas. So I'm based in Texas, and basically what we do is we help tech talent in Latin America connect to amazing opportunities in the United States. So our ultimate goal is to generate perfect matches between our engineers and our partners in the US and establish long-term relationships. So the way we do that is by having a developer-first business model. But what does this mean? Our devs work directly on the engineering teams of US companies and make sure that they have influence over the teams, that they don't miss out on important decision-making, that they are not treated as freelancers, and they have all the equipment and resources they need in order to be part of a team and not just jump from project to project. We also advocate for bonuses, raises, and recognitions to the US teams. And we also have engineering mentors who give guidance for career growth and help build out these plans. So you really don't feel as alone if you were maybe just a freelancer or working at a traditional software factory. Okay, so this creates a community of Latin American developers that are constantly sharing information, they're sharing knowledge and collaborating. So you work for the US, but you have teammates within your city, within your regions that you can discuss, debate, and collaborate with each other, whether that's working remotely or hopping on to one of the offices that we've established in Uruguay, Colombia, and so on. We're continuously adding more office space so that all of our developers can collaborate with each other. We also don't work by fixed hour contracts. We're not a software factory or outsourcing product company or even a staff augmentation company. We really do try to have the developer first mentality and help build a long lasting career for the people who come and join our team. So our current facts, in 2018, Austin Software was founded. And although our headquarters is here in Austin, we have offices in Montevideo, Uruguay, Buenos Aires, Santiago, Medellin, Bogota, Mexico City. And we are, like I said before, we're continuing to expand in different regions. We have 25 partners, and 2 of them are actually US unicorns. So that's pretty cool. Definitely working on some new age products here. Also want to just thank all the communities that support the Austin Software Tech Talks. So that's React Buenos Aires, Devs Chile, Noobs.js, Montevideo.js, Python Chile, and Node Colombia. It's because of the communities that we get to work with and partner with. That's the reason we're able to have these tech talks and just be able to continue to feed into the community and just have a good time and learn something new. So with all that being said, I also want to say that this tech talk is being recorded. So we will have that on our YouTube channel, and we'll have a end of, how do you say this? It's a survey for the tech talk in the end. So please be sure to answer the questions there so that we can continue to make these tech talks better and better. All right. Well, I'm going to pass it over to Francesco and Fede. You guys take it away.
Right. Right. So let's start. Let's get into it. First of all, again, thank you very much for your time, Francesco. And it's really nice to meet you. Well, let's get right into it. So first question, like, what's Docker and why should I care as a front-end developer, back-end developer, engineer in general?
Nice. Okay, so first of all, thank you so much. But since I don't have any slide, I'm sorry, it's my fault. Can I share my screen? And I think that what I'll do is I'll use maybe some memes during this presentation. So I'll try to explain something in the easiest way. By the way, if this is already a hard thing, because we can also get something against, of course, Docker, but some of them can be useful while I talk. Okay, so basically, okay, so this is my favorite one. Okay, so this one, it works on my machine, and then we will shift. So the problem is that when we develop some software, we do this on our machine, or the developers, they do this on their machines. And usually on their machines, everything, there is like a setup process. I don't know, I need to install Node.js. Node.js is a JavaScript runtime environment to run JavaScript stuff, basically. You can install a PostgreSDB. The problem is that usually the production environment, the production machine is not the same, or it's very rare that it has the same operating system than what you use. Think about Mac users, Windows user. I am on a Windows machine now. It's very rare that you have like a Windows 10 home edition on a server. There is something strange, I think, in that case. So what's the problem? If you use softwares on different operating systems, you can have some issues. You can have some hiccups because there could be a different configuration. There could be something which is not maybe the same of the same version. So, for example, I don't know, like you have developed your software on the Node 16, but on this production server there is Node 14 because, I don't know, they have not updated the latest version of Node. This can also be an issue. By the way, there is like, I don't know if you know the async await, the top async. So this can also be some known issues, but let's not go into detail. So why is Docker something cool? Docker is not something that you just install on your machine, but is a platform. It's a platform which helps you to containerize your application. So Docker doesn't make sense without an existing application. So it's a tool, it's like a box. So a box makes sense when you put something inside that. A box without nothing inside that, you can just put this somewhere. I'm full of boxes in this house, by the way. So yeah, so this meme on the right, it's one of my favorite ones. I need to make this again. So it works on my machine. So the idea is to create the same environment on the production machine and the develop machine, or the developer's machine. Because think about if you have, for example, different developers. One develops on a Mac machine, one develops on a Windows machine. And last thing, I like about this one, work at finding dev, ops problem now. So, so like this was where the developers like some years ago, okay, I've developed the software, then there is a ops problem. Ops here, it means like operations. So like sysadmins, people who their job is to put the code in production. This is a profession. This is still a profession, by the way. And this is fun, but this is also bad, because if you're paying, you can really lose money trying to set up a configuration. You can keep that updated, and this is a job basically that you have to do this. So, and I think the main problem is, if you have a problem in your code, if you have a bug, you'll never know if it's a configuration problem or a code problem. So sometimes you really don't know where. So having less things is better, so you can focus more on the bugs on your code and less on the configuration, the operating system, what are you doing, some ports. So this can, of course, Docker doesn't solve all the problems. So you still have the problems. We need to have the ports open on the machine. It also adds another layer. So yeah, so this was just the introduction.
Yeah, great. So I'm seeing some of those memes that are kind of negative about Docker. So that brings me a question, like, how does this affect my workflow? Isn't that in like another layer inside my computer when like I have a computer running like 100 programs already? Like, is it worth, like, can it be a problem?
Yes, it's another layer, but also, let's say, an operating system, it's also another layer. We can also do this like in direct, bytecode directly into the machine. This is bad. Usually having someone who handles stuff, it's a good thing. What, as I said before, by the way, just a little parenthesis, when we talk about Docker and containers, a lot of people give this for granted, but let's be precise here, even if we are using memes, so it's even harder. It's when we talk about containers, in 99% of the cases, we are talking about Linux containers. So containers who runs natively on Linux. Docker runs natively on Linux. And maybe some of you, if you already know Docker, maybe you have used Docker on your Mac or Windows machine, so you can even have a question. But Docker runs natively only on Linux for Linux containers. And so, so maybe we will talk about this. And the idea is that there is the same experience across different operating systems. This is the dream of the developers. You don't have to think that you have something on your Mac which doesn't work on Windows, which probably on Linux, you have to install something different. So this also, from my point of view, I have a Mac, a Windows machine, a Linux machine, a Raspberry Pi. Docker runs also on a Raspberry Pi, which is an ARM processor. So that's not something which is for granted. It runs also on the M1. They had some problems in the beginning, but now it works. And yes, so the main advantage is that it works agnostically between operating systems. So this is, I think, one of the main advantages.
It's really interesting. So imagine that I'm like a front-end developer or specifically a back-end developer. Like, is there any type of applications that that would leverage more the usage of Docker, or is there anything like in particular that I should take into account? Like, can I use it in my project, for example?
Nice. Yeah, thank you. This is a good question. By the way, it's the good thing is that Docker works with all the programming languages and all the front-end, back-end, or with database. We will see something if we have some time for the demo. If we make a demo today, we will make a Node.js example, spoiler. But I think that for the backend development, it's more used. It's even more, it's used more, maybe a bit more for backend. But as you do this for backend, you can also containerize a front-end application. Just let me say that, for example, an alternative to Docker, for example, is Vercel. I don't know if you know Vercel. I have no problem in saying that Vercel is a very valid product. I know also developer advocates there. They're always all some fun. I think I have some swag coming from Vercel in some days, so I can't talk bad about Vercel. I'm joking, but no, I'm joking. So I'm great fan also of Vercel, Netlify. But you can use, for example, Docker even on front end if you want. You can have a container, for example, of a web server. It depends basically on if you have another legacy project. But let's say mainly backend, but it can work literally with all the applications. Yeah, I'm also preparing a webinar about using Docker for a local environment for the Solidity development, for example. But I don't see a lot of content on the internet, so probably I'll be one of the first ones who is doing this, but I'm still working on this, I'm sorry. So I can't do this today, but yes, this is the idea that you can really containerize basically all the applications. So it's operating system agnostic, programming language agnostics, and also type of application agnostic. So this is what really made me fell in love with Docker, because I don't have to think about something specific, Java, something, or I don't know, or Python, version Python. So it's a very cool technology, I think.
Yeah, I'm sure that if you try to run anything related to Solidity inside a Docker container, you'll be the first one facing the errors. So that sounds very interesting.
I'm working on this. Probably I'll send you the link. Probably.
Yeah, of course. Sounds interesting. So well, basically, if it runs on a Linux environment, you can run it in a container. That's basically the thing.
Yes. So yeah, basically Docker is a program that runs natively on Linux. And one of my best, I think there are two main definitions of what is a container. And there are two definitions. One is logical and one is technical. The logical definition is that a container is a standalone single unit of software working, like, I don't know, a login application, a Twitter bot, something like that. So this is an application who makes sense to, let's say, create a Docker image and then a container. And then from the technical point of view, so maybe this is more for the sysadmin, Docker container is a process, is a Linux process. So for example, if you are a Linux master, you can also handle containers also using the PID, you can kill the process, so you can even work in a very fine-grained way. And I'm more from a developer point of view, but for example, you can also consider containers just like normal Linux processes. You can use IP tables if you're an expert in that field. I'm not an expert in that field, but I have an idea. So for example, this is this is also why containers are so easy, for example, to run, because it's like literally like running a process, and it's not like a virtual machine. If you want, we can make a comparison, because otherwise it's not a Docker introduction webinar. This will be removed. That will be illegal.
Yeah, of course. That was the next question that I was going to ask you. Like, this sounds really familiar from like a long time ago, when virtualization was like the dominant force in this field. Like, whenever you need to run, like, I'm on Windows and I need to run like another operative system, like I would spin up a virtual machine. Like, how is this different? Because I'm seeing that it solves like really similar problems.
Yes, and so now someone could come and say, okay, Francesco, but this problem has been solved like 20 years ago with virtualization. So what is a virtual machine? Virtual machine is basically a machine which is virtual, I'm joking, but it's basically you create a virtual environment of an operating system. Why should you do this? Because you want to have, I don't know, something that you can reuse on other operating system. What's the problem of virtual machines? Sorry, I don't have the slides, so I have to steal other images. So I've looked for Docker VS versus VMs. So all the credits to the people who made this, by the way. Maybe I should create, maybe I can use the official Docker Docker blog, so I can use this. So what's the difference? I should make this one. So if you check here, I don't know if you can see the mouse. Can you see the mouse? Okay.
Yeah.
So here on the right, there is this, which is what you have if you have a virtual machine. So you have an operating system, just like infrastructure. Then you have this, which is an hypervisor. So basically something which lets you to run an operating system on the top of an operating system. And then you have this whole virtualized environment. So this problem has already been solved. What's the problem here? The problem is that when you run this virtualized environment, this is very heavy, because even if you have, and the virtual machines, they have improved during the years, they try to make this as simple as possible, because sometimes, for example, sometimes you don't even need the UI, because this is just, you just need, for example, basically an operating system when you just want to run some process. But of course, running an operating system is not the same as running a process. So that's the difference. The difference that you see on here on the left is that you have the operating system, the host operating system, and then you have Docker installed. And Docker takes care about all these containerized applications, which are processes. Okay, and the good thing is that this host operating system can be different systems. So once you have this, basically you can have how many containers you want. There are some memes like that. Okay, they use some RAM, but I would suggest you to run, instead of 10 containers, 10 virtual machines. And then if you still have some memory left, you can send me a message. So of course, this is
that's the real world test.
Yeah. Mm-hmm.
Yeah, totally. So basically, like if I use Docker for this kind of thing, like the resources are going to be like pretty much better utilized, like compared to virtual machine.
Yeah, and of course it depends. Of course, if you run a heavy process, you have that heavy process. You have still a little bit of overhead, of course, instead of just running the process, let's say, natively. The problem is that we don't want, if you are running containers, you don't want to have one 90-ish computer with that software installed and running like that. Otherwise, you will just use your PC. You want to scale at some point. You want to reach 1,000 users, 100 of thousands of users. So in that case, you can't really use just one machine. So in that case, you start having different machines, and then there will start your real problems. So of course, this is an optimization, which I think that can save you some time. And you will also, something that I really like is that if you have these containers images, you can use this on any machine when Docker is installed. You're not dependent on AWS or Azure or DigitalOcean. So you're also cloud platform independent. So if some of them they ask for more money, you can also switch, and that's where you save money, not just saving a little bit of let's say RAM or CPU memory.
Great, yeah, that sounds amazing, especially for a wallet.
Yeah.
Well, so another question that I had that I wanted to ask, like, how do I start using this? Because like whenever you start reading a little bit about Docker, like Docker means a lot of things. Like there's Docker desktop, there's like the Docker engine, and there's a Docker company. Like, what do I do like to start working, and how like all these parts fit together?
Okay, yes. Okay, first of all, it depends on your operating system. I think I have one of the, I'm not making a shameless plug, but if you can check install Docker on Windows, I think I have one of the fastest tutorials. I made this a couple of years ago. So basically you can install Docker desktop if you have a Mac or Windows machine. If you're Linux, you just can install it like there are some very easy tutorials. So we will not install Docker today, but it's something super easy. If just let me tell something super fast. If you want to follow along with me, but you don't have time to install Docker, what you can do is this. You should have a Docker Hub account, but if you can follow along, you can do this. You can go on this page, which is called Play with Docker. And this is basically, by the way, this uses a technology which is called the Docker in Docker. I know there are also some memes about that. By the way, Injection is one of my favorite films. And basically here, you have a Docker environment in a browser. I don't know if you've ever seen this, but here I have Docker, but I'm not on my machine. This will be destroyed in 4 hours, as you can see here. Otherwise, you can literally deploy something here and make it public. And here you basically you have a Docker in a browser here. You also can install the port. You can also use this, or I use this on my machine. So, for example, if you can want to follow along, you don't even have to install Docker to test this.
That's amazing.
Okay.
Well, so I'm not sure, Francesco, you want to dive into like how Docker works?
Yeah, I think that, okay, so let's say in 30 minutes, I want to make as many examples as I can. So I want to, first of all, maybe make a real hello world. Let's make this together and try to understand what the hell is going on, because there are so many things happening under the hood. So maybe I can close this.
Yeah.
And so if you want, you can follow with that. And okay.
Yeah,
so
and I want to make sure. I want to make sure that people knows that they can send questions like in the chat, and there's a QA section, and we'll be able to read them, and we'll be answering them. Okay, so yeah, everyone feel free to ask.
Okay, perfect. So I don't know if you can see the screen here. Just let me put this 1 second. Okay. So I am on this machine when Docker should be installed and also running, but to check if Docker is installed and up and running on your machine, a command that you can do, there are different, but you can say, I think you can do Docker info. With Docker info, if you have basically some information about your machine, and here basically, for example, here you can see the architecture. If you use this on a M1, you have architecture ARM, I think, or something similar. And here I have the information about the machine. I have no containers because I cleaned this up. This was a mess before this webinar, but I want to make this a little bit cleaner. So now, the basic concepts are containers and images. So if we understand the difference between the two, you already have taken already a lot out of this webinar. So basically, let's make it super fast, super easy. If you know the object-oriented programming, you can think about an image like a class, and as a container like as an instance of that class. So basically, an image is a file that contains all the code, dependencies, and other stuff, configuration that you need to run a container. And a container is a process that runs based on that image. I don't know if that was clear. So this is basically, of course, the simplest definition that can come up in my mind now. Okay, so let's check some basic commands. I don't know if you can read, but okay. So for example, if you want to see the containers that are on up and running on your machine, you can do docker container ls. This is one. This is the long version. I'll do this. This is just one. Container ls, and as you can see, I see nothing here. If you're lazy, like Emil, you can do docker ps. Okay, it's faster. Okay. Then, if you want to show instead the images on your machine, you can do docker images or docker image ls. So as you can see on this machine now, I'm very clean. So I don't have any image. I don't have any containers. Okay, so what we can do now, okay, so let's say that I want to test Docker. As I said, let's make an example together. So what's the simplest example that we can do? Okay, so I'll do an example that I'll try to explain step by step what happens. So if I do this, Docker run hello, no, hello world. Okay, so this is a very simple command, but a lot of things will happen if I do this very simple command. Let's see what happens together. I don't know if you already done something like that. I think yes, but
yeah.
there are some questions. Let's see what happens. Okay. Unable to find image. Hello world, locally, pooling, some stuff happen. Okay. Okay, let's see what happened. I see here, there are some bash, let's say, messages. Okay. So, and I am already again on my terminal. So basically I got an output and then I'm already on I'm again on my terminal. So let's see now what happened under the hood. So let's do the command again. So docker ps, and I don't see any containers here because docker ps just shows the running containers. So to show all the containers, also the stopped ones, I remember that containers are processes. So if you know, in Linux, there can be like stopped processes, running processes. So you can think about processes. So docker ps-a, here you can see that we have this. So we have this container with this ID. This is the image used for the container. Remember that a container is an instance of an image. This is just to understand the idea, of course. This is exited. Okay. It seems like an error, but it's not. Ports not. And then we have also this laughing Archimedes. You can define a name when you run a container. If you don't define any name, it will be given a random name.
Great. Yeah, so it behaves exactly as a process. Like it has an status 0. Like when it's successful, it ended.
Exactly. And why is it stopped? Because a process doesn't have to be running over and over again. Of course, for example, if you run a node process, probably you want to make it up and running because you want to receive maybe some HTTP requests. If you have any questions about a node, I think also Fede can help you. So basically, if you want a backend service, in this case, for example, you just want to type something on the screen and then it exited. So a container is not something which has to be up and running 24/7. It depends on the service. Here, of course, this is an hello world. So it's like, let's say, it's like a console log hello world, and then it exits. Okay, now let's see the interesting part, because this was not the most interesting part. So if I do Docker images, can you see? Can you remember that before we didn't have any image? So what is this? Who made this? Why do we have this image with these sides on this machine? Okay, the reason is when I say docker run, this is an image, by the way, this is not a container. What happens under the hood is this. There is something called Docker, no, not Docker Hub, but Docker Hub. And if you know GitHub, you can think this as an analogy. So Docker Hub is basically a place when there are all the images, not all, but many of them. You can see here about 9 million of available images. And these here, you can understand the Docker ecosystem, because here there are, can you see, official images, Python, Redis, Postgres, Nginx, Node, MySQL. And this is the power of containerization. I have not done the Postgres image on the Nginx image. The Postgres team has created a Docker image for them because they want people to use Postgres. Okay, so this is basically the secret and the ecosystem of Docker itself, because otherwise we should create all the images and containers all by ourselves. So that will be really a mess. So let's just let's see if we find this. And of course, remember to don't download the random stuff from the internet. But this is not just for Docker Hub. This is for GitHub, NPM, and basically all the websites. So, so of course, for example, here you can see that this Hello World official image has been downloaded 1 billion times. So probably this is something that you can use. And here there is the definition of this image that I've used. And here there is like a README. And if you type this, basically you have this output. So basically we have used this image on Docker Hub. Okay, is there any question here?
This really feels like the GitHub of like the GitHub of Docker images. Actually, you can search for everything, like any dependencies.
Yeah, basically, if you do Docker run, it's like if you do Docker pull hello world and then Docker run hello world. So this is what happens under the hood. Okay, so this is something. This is an example. And okay, so if we don't have any other questions, I would like to skip to the node example.
Does this do, like, for example, can you have like private images? Like, does this really work like GitHub? Like, for example, my organization can have images.
Nice question. You can have one private repository for free, and then all public repositories, and then of course you can have the premium account or whatever. So this is the idea. Just let me say that Docker Hub is not the only Docker registry. There are many. Usually all the cloud providers have their own registry, container registry. For example, Amazon has one called Amazon ECR, and also other, I don't know, I can't remember the name of the other ones. So you can also have your own registry and host this somewhere. You can also have your own Docker registry. I think now the image is called Registry 2. Of course, this is an image on Docker Hub. It should be this. I don't know if it was this one. I can't remember now the exact name, but it should be something like that. Okay, registry. I think it's this one. Yeah, registry 2.0. So for example, this is an image of a Docker registry. So if you deploy this, you have a Docker registry. So you have something similar to Docker Hub. Of course, Docker Hub has more, you can do more stuff, of course, because they've worked on this. But I think a Docker Hub is like something which starts from something like that. Okay, and this is just the basic example. Okay. Okay. So, okay, so I think that now if we want, we can make another example. By the way, this is the very first example that I also did in my very first webinar about 1.5 years ago. I hope to make this at least decently. No, I don't know. Let's see. A lot of time has passed since that time. Okay. Okay, by the way, I am on Visual Studio Code. If you know this editor, I also the Docker extension. You don't need the Kubernetes one for you, but you can use this. This sometimes it's useful. You can also see the containers here. But the main reason why I have this because it helps you when you create the image. Okay. Okay. So now let's create. Can you go, Fede?
Yeah.
Can you go? Okay. Okay. So let's create a simple node hello world, and let's try to create a Docker image and container out of that. Okay, so first of all, if you want to create a Node.js application, we use Express here. We can do this. So we can initialize this project. We have this package.json which contains all the dependencies, or at least will contain the dependencies. Then we can install Express, which is a framework of Node.js. Okay, we're not doing something super advanced here, but we will do something, I think, pretty easy. And okay, so let's create a file called index.js. This is not Docker stuff, by the way. And here, what we can do is to do a very simple, let's see, the GitHub Copilot. Have you ever tried the GitHub Copilot?
I haven't tried it yet, to be honest. I read a lot about it, and saw some great tweets about it, but haven't used it.
Let me tell you something. I've been one of the very first people who got GitHub Copilot. It was July 2021, but I haven't had time to use that. People will hate me because someone is still waiting for the beta. But okay. So here basically I'm creating a very simple hello world. Okay, check the data. It's literally writing that. If I do this up, there we go. This is the endpoint.
That was way too fast.
Yeah, the problem is that it's too fast. Yes, true. Up, listen. So basically here I'm writing a very simple, very simple word. Let's see. And then I think we can just log, I don't know, something. Hello. What is that? There we go. Okay, so what is this? Okay, so this is not, for sure this is not exciting, but at least I've done this in a very fast way. So now, of course, we are simulating. Think that we have at least, I don't know, coded for a week or so. Maybe we've done something better than this. Okay, so if I want to run this, this will be interesting, I promise this. So if I want to run this on my machine, by the way, on my machine, I have, let's see the node version that I have. I have a node version 16, okay? So if I want to run this on my machine, what I can do is, of course, node index.js. Okay, let's see if I made this correctly, because I remember that the last time it was not. Okay, so I've done the, you can really panic if this doesn't work. Sometimes I mess up so much on the hello world. Okay, so this is not exciting. I'm not using Docker. So let's pretend that you have done something a little bit better than this, okay? And now you want to, what usually is called Dockerize this application, okay? Okay, so how do we do this? Because we should create this image. So how do we say to Docker, okay, we want this somewhere? There is this process which is called like this. So we create something which is called the Dockerfile. This is one of my favorite parts. By the way, I also like that on VS Code, you also see a Docker icon. Because, for example, if you misspell that, you can see, no, maybe, I don't know. But I don't know.
Probably
maybe,
because you write it correctly the first time. So
I don't know. Yeah, probably. But sometimes this saved me. So, by the way, a lot of things in Docker you have a default one, but you don't have to use a file called Dockerfile. This makes the things just easier. Okay. Okay. So, a Dockerfile is really a very simple text file without an extension, when you can write some commands, basically. Okay, now we will write some of them. Basically, usually on Dockerfile, you have something like that. You have a key, usually it's uppercase, and then you have some value. Okay, something like that. Okay, so this is usually the how is structured a Docker file. So for example, you can have the from. The from is basically the basic. Can you see here, if you have the Docker extension on Visual Studio Code, you also see a definition of what the from is. So basically, we can define a base image. So basically, we will build another image on the top of another image. So for example, here we can use node version, let's say 14. Let's say that for our project, our manager said that we have to use node 14. So for example, here there is a problem because we have node 16 on our machine. The project, they said that they want this for node 14. So I don't want to uninstall node 16 on my machine, but for the project, they want node 14. Okay, so I can have two choices. I can say, okay, let's try it. Maybe it will work with node 14, or I can create an image using node 14. So can you see the advantage here?
Yeah, that's totally better, because maybe I have another project that uses Node 17 or Node 12, and that would be a problem if I uninstall my current version.
Yeah, and just let me tell you this. Okay, if you use a Node and you know Node, there is something called MVM that can save your life. You can switch. But think about PHP or Python version 2 and 3. It can really be a mess. So with Node, maybe you just have to remember to switch with MVM, but this is not something that you can have on machine. Or maybe you just want to, have this for maybe just one day. You don't want to install Node 14 just for this little project. Let's go on.
Yeah, okay. Especially on other languages that uses dependencies in different ways. Like, as you mentioned, Python, like that installs the dependencies like globally. That can be a mess.
Yeah, the advantage is that, of course, if you are a master, if you are a Python master, you know how to install all the versions of Python, you know how to handle them. But if you are not an expert of a language, usually you don't have all the knowledge of how to switch between different versions. Maybe you, I don't know, maybe you just want to run a PHP project just for once. So in that case, you really see the advantage. Okay, so the work there is basically to make things a little bit organized. So this will literally just create a folder called app in the image file system. We'll see this. Then there are other commands, which are this one. So the copy command, as probably you can imagine, it will copy something from this folder inside the image file system. So basically we are defining something to define the image file system. Okay, and here we can do this. We can copy the package.json in the same, this dot, it means inside the image file system. There is this little hack, which is putting this star here, which is basically using regex. We hold that all the people here, they love regex. And basically, if you have a package that -lock.json, it will also copy that one. Otherwise, it will not complain, because if you try to copy something which doesn't exist here, the build image will fail. But this is for our safety, because we are trying to copy something which is not there. Okay, then we can do this command run, which is basically this GitHub Copilot, which is spoilering, that basically we can run command. Think about, you can run apt-get update, you can install curl, so you can literally run whatever you have done on the terminal. Okay, so okay, of course, for production environments, you should you can delete the cache. Of course, we're doing the simple stuff here, of course.
Okay, and why don't I copy the Node modules, for example? Like, why don't I install it locally and copy my Node modules inside a container?
Okay, okay. The problem is that when you, for example, when you commit, I hope that when you create your Node project, thank you for this question, by the way, I was expecting this. When you give your project to someone else, you don't commit your Node modules. Here we will talk about this, because here I have these Node modules here for me, but I don't want other people use the Node modules which has been downloaded for my file system for there. Okay, so now I'm doing something that, for example, you can complain, because what I'll try to do now is this. I'll say copy everything from this folder inside the image file system. So, but please give me 5 more minutes. So if I do this command, basically everything which is in this folder, it will be copied inside the image file system. Okay, just we have to fix something here. And here, as the last command, we do something which is called command cmd. So and this is, here GitHub Copilot failed, because you should not do this command. This is wrong. You should do this exactly the same that I've done on command. So index.js, not index.js. Okay, now if I do this, the Node modules folder will be copied inside the image file system. I don't want this. So I can do things here. I can either just copy the file that I need. For example, just index.js, it's enough. Don't even really need the Dockerfile inside the image file system, because the Dockerfile is the file to build the image itself. Or I can use something which is called the Docker ignore. So if you know Git, you probably know what the Docker ignore does. Do you have an idea?
I believe it actually, you tell, hey, do not use these files.
Exactly.
Ignore these ones.
Exactly. For example, if I create something like that, another file here, and I say in the Docker ignore this, it will not copy this file. Okay. This is to avoid to have this this file. Okay. So I think we are done. So we have done the Dockerfile and the Docker ignore. So let's super fast recap. These are all the commands. Okay, so we have created a Dockerfile. Now we have to build the image. So what we should do is to make this command. I don't know if you can read here.
Yeah, perfect.
Docker image build, then -t, which stands for tag, which is basically the name of the image. We can call this like node app, and then the path of the Dockerfile. To build an image, you need the Dockerfile. Usually, when you run this command, you are already inside the folder when the Dockerfile is located. But for example, you can also do this from another folder, or maybe you have, I don't know, multiple Docker files, and here basically you give also the relative or absolute path. But usually you are already inside here because you have a Docker file inside the same app. Okay, let me tell you that we don't really need to add this image. So what you probably see in a tutorial is just this Docker build. But usually is the Docker image build if you want to make this the long and the new format of the command. Just to remember that when we build, we always build an image. We never build a container. If you say tutorial when they say, let's build a container, run away. Okay. And now we are building an image. And as you can see here, okay, so it has been a bit fast, but can you see here, 1 out of 5, we are basically done doing some layers, and we are doing one by one all the layers, okay? Okay, and so we have created an image. Let's see. Do you remember which was the command to show the images?
Docker images ls, can it be? Or
no, no, or Docker images, or Docker,
Docker images.
Image ls. So Docker image ls or Docker images. Okay, and now as you can see here, we have this this node app, sorry. This node app image, okay? Okay, perfect. So now we can try to run. Just let me add something here. Maybe we can, no, it's okay, it's okay. Now let's run the container based on this image. So what we can do is do Docker. Let's do this in the most simple possible way. We can do Docker run. Let's add some options. For example, you can change the name, like this is like I don't know, node test. You're choosing the name of the container. We can also add this -d, which stands for detached, so it will leave the command line, the terminal open, free, let's say available, and then the name of the image, which is this one. Can you see that here there is this latest? This is a bad decision of the Docker team, to be honest, because basically latest means default. So if an image doesn't have a version, you see latest, but it doesn't have to be the latest. It's just the default, to be honest. So what I'll do is this node up. Okay, I can even do this, but latest. I don't really need to add this part. Okay, for example, I don't have that. But let's try this. Let's see what happens now. Okay, we have this ID. Now let's try to do Docker -a. And as you can see here, if you can see, there is this, just a little trick. The latest containers and images are always on top. So don't look behind. If you have done something new, it's always the one on top. This took me some months to check this. Okay, so as you can see here, there is something which is up and running still, because now we are running this container. This is not in exited way, because we have done this node index.js. When we do node index.js on our machine, it's a process that doesn't end, because it wants maybe to receive some HTTP requests, for example. Okay. Okay, so first of all, let's see if it worked. Let's see. No, wait a moment. Let's see if it worked. I don't have it. Why? Maybe it's because. Okay. Okay, so I made a mistake, but so I'll fix this. The problem is that I haven't defined a port. So usually the ports are closed by default. So when I've done node on this JS, I've done this intentionally. No, it's not true. But let's fix it. Let's fix it now. Okay. So, and I also tell you a secret now. So another thing that you can say here, we can define this. We can expose a port. Now, don't say this around, but this is not really needed. This is just to inform that this port will be used. But if you don't use this, it will work anyway. This is used because, for example, if you want to inform that this port will be used, you need to text this here, but it's not really needed. What you really need is this, is that you need to export to publish a port. So I'll not build the image again, just to show you that it's not necessary. So basically,
so it's like a message. It's like a message for people that are going to run the image.
Exactly. Or for example, yeah, for example, at least you know that this project will run on this port, but the real part, important part is this one. Maybe I need to change the name because otherwise it will come. No, let's try to this. I want to make a mistake, so I want to receive the error messages. So let's try to run this again with the same name, but telling that we want to expose this port. This means that it's a mapping from internal to external port. I'll use the same port. I should get an error. Conflict. The container name, no test is already in use. So here I can do those things. I can either choose a different name or remove the old one. So let's do this, so I'll show you how to remove a container. So to remove a container, we have different options. Something which is very easy. It's like you do docker rm, which stands for remove. And usually you can, for a safety reason, you can just remove container which already has been stopped. For example, if I do docker rm e7, which is the first IDs of this one, it's removed because it's stopped. If I try to remove this one, F1, it should complain. It complains because you can't remove a container which is running. Okay, but since we know what we are doing, we can force it. Okay, otherwise I should stop it and then remove it. So let's be rude and let's remove it. Okay. Okay, we don't have containers anymore. So let's try again. Let's see now. I've done something decent. Okay, here. Okay, so it was the port. Okay, now let me show you something which probably you don't see this often in tutorials. So let's try to step into a container, because this is a very important concept. And so how do we step into a container? If you come from the, let's say, Linux world, the sysadmin world, what you are thinking, maybe it's like a SSH or something like that, okay? So how do you step into a container? You do something called, you can use a command which is called docker exec, which stands for execution. So basically we can execute another command on the container, because as I said before, when you do Dockerfile, this command is the default one, but I can override this and run another command on the same image. So for example, I can do this, docker exec -it, I stands for interactive and T for pseudo TTY, and then the name of, or the ID of the container. For example, I can run this 08, and then bash. And here it happens some magic, because as you can see here, I see root at 081 EA47/app. So now I am inside the file system of the container. And let's see something, because for example, here, you don't see the test.txt file, because I've defined this in the Docker ignore. But the most important thing is not that, but is this one. If now I say this node -- version, I see the version 14, because I am in the container, not on my machine. If I do this on my machine, this is node version 16. Instead here, I am in a Dockerized environment. As you can see here, this /app is the folder defined in the Docker file. It's not a must, but it's good. Otherwise, everything is in the root folder. Okay, and here I am. Here I am in this container up and running. This usually it's nice because it helps us to understand what's going on.
Interesting. So basically, you're running an instance of the bash program inside a container.
Exactly. I can do this because, not because it's magic, but because the node image is based on a Debian distribution. So the people of the node team have created this not out of the blue, but the node is on a Debian image. Of course, also the Debian image is on Docker Hub. And so you can...
So basically I have an entire instance of Debian that everything that I can run on a Debian instance, I can run it there. Like I run into bash and I can do anything.
Exactly. For example, if you use something which is called like a node alpine, which usually is to use seamless memory, you don't have bash, but you have just sh. So you don't have even maybe URL or other stuff. So it also depends on the image that we use. But this, for example, is very useful also to debug this, to see what's going on, to see. Here we are inside the container itself. So this is usually, and of course, here I've done bash, but for example, I've skipped that example. But for example, if you know Postgres, you can do docker exec psql and use psql inside the Postgres image. So yeah. So
okay. So for example, I would run a node version that would be based on Alpine if I wanted like a more slimmed down image. Like for example, that ties to a question that we have in the chat about like that says, should I worry about the size? Like, is there any limitation? And that he saw that Express app is almost 1 GB and that can grow fast.
Yes. Okay, let me say just a couple of things. Of course, you can use a different version. It's okay. Usually for tutorials, something like that, I don't use the Slim or Alpine because, for example, I want to make bash. I want that everything is here. But of course, you can use that. Some people also recommend that. Maybe you need to be careful about the security. I think Alpine had some problems. Let's say when you have, for example, you want to run some security scans. You can even maybe have to install but you can do this. You can, for example, you can do this run apt-get install and whatever you want here, because here you are in a Debian distribution. You don't see Debian. To see that, you should go. By the way, if you have this Docker extension, you can also go here, for example, and okay. And here I am in the node official image, and here, yeah, you can. Yeah, they work a lot on this stuff, of course. And here they say all the variants. Can you see here? They're explained here. There you go. I know this because it is written here. And I can also say in the bash. And here they are explaining basically whatever is going on. The Node team is is great. They keep this kind of images always updated. Also, let me say the Node images. This is not sponsored by Node, by the way. Even if I have one friend who is a Node maintainer, hi Matteo. It's also multi-architectural. The Node has also some ARM images. Let me see if I find them. You have also the ARM support for Node. Otherwise, you would not run Node on, for example, on an ARM system, for example. Okay.
Yeah, great.
So,
and is there any limitation about the size in particular? Like,
what do you mean?
Like, are there any limitations around the size or anything?
Limitation about what on the
like about the image? Like, can it be like way too big or something like that?
It depends on the image that you use. Just let me tell you this: the image on Docker are based on layers. So, for example, if you on your machine you have Node 17, Node 14, and Node 16. You don't have 1 gigabyte and 1 gigabyte and 1 gigabyte. You have probably 1.1 gigabyte because a lot of stuff is in common. Okay, so this is very important because if you do Docker, let me exit here. If you do just Docker images here, Docker images. Docker images here, you can see this, which is it's a bit big, but if you don't know, you pull, for example, Node version, I don't know, 15, and the pull is the command to get an image from Docker Hub. If you do this on a live stream, usually it takes more time because we are also streaming on your machine. So it's also usually it's a bit slow. So in the meanwhile, we should find something interesting to say. And but you don't see this layered system. It seems that all the images, they occupy one gigabyte, but that's not true. They have a shared layers. Okay. Now it's taking a while. Okay. Okay, so I think that it's enough for today. I don't have time for the Docker Compose, but next time, if you want, I hope that you enjoyed this. This has been a very practical and meme and demo approach. So I promise that next time I'll also try to prepare some slide. But if you want an episode 2 with the Docker Compose, you can do this another time. I'm open to know all the questions that you want. Thank you so much. I'm done. Sorry, it's still downloading some stuff.
No, that's great. Thank you so much for speaking with us and walking us through this. And just so everyone knows in the chat, he also has you have a Twitch account, you have a YouTube account, and so can you tell us what the handles are for those?
Okay, I'm just on Twitter. I'm trying to reach 100,000. So if you want to help me out,
Twitter.
It's Francesco Ciulla with a 4. Don't ask me why I put a 4 at the end, but it's Francesco Ciulla with a 4. So if you want, you can hit me up on Twitter, and on YouTube it's my name. There are various Francesco Ciulla, but I am the one with more subscribers of Francesco Ciullas. So I'm happy with that. And on Twitch,
that's exactly right.
And on Twitch,
and your Twitter handle in the chat.
Yeah.
Right.
Yeah. I don't know.
Awesome.
Okay. Yeah. But thank you so much, because I hope that at least we have understood something. It was something. Yeah. But I always like to talk about Docker. This is very similar to my very first webinar, but I hope that I've made something a little bit better. At least I remembered to make NPM in it this time, so I'm happy with myself.
All right, well, great. Thank you so much. For everyone else still with us, we appreciate you so much, and it would mean the world to us if you would fill out our survey. I just added that into the chat. It really helps us make sure that these talks are relevant and useful to you. It also it's all anonymous, so please feel free to give us honest feedback, and we'll do our best to implement anything else, any of your suggestions on the next Tech Talks. With that being said, thank you to Fede, thank you to Francesco, and we'll see you all later on. Thank you so much.
Thank you, Camillo.
Thank you very much.
Take care.
Bye-bye.
Goodbye.